All right, so we're picking up where we left off. And so we left off with this last question about a kite, right? We talked about the diagonal due to its polygon, right? It bisects the angles. So notice that this is the same. So say that this was 40 and this was 40. Again, when you bisect, you're cutting something directly in half, okay? So all of these problems so far are what we're doing is we're exploring, right? So a lot of times you use tools in the world to explore relationships. And then when you start to see connections, right? You've started to, you notice patterns, right? You notice patterns and you're making connections, then you're going to write a conjecture. So again, this is just a hypothesis, right? Sometimes we are correct in our conjecture, other times we're not, and that is okay. What we want to do though is we want to prove, and when we prove, you're trying to convince yourself, maybe you're trying to convince me that your conjecture will always be true. So like when you're solving 1 plus 2, right, it will always give you 3, and so we can kind of write a proof that has to do why will this always work? Okay, and a lot of times our proof is in our flowchart. Okay, so let's come back to kites. Okay, so here is our next question. Kip shares his findings about his kite with his classmates, and Carla wants to learn more about the diagonals of the kite. So Carla sketched a kite at the right onto her paper. Okay, so explore. Let's trace this diagram onto our paper, and then consider how the diagonals may be used. Okay, so when I look at this problem, I already have one diagonal, so I need another diagonal. So I'm going to draw a second diagonal right there. Okay, so something that I might say is that if it is a kite, right? Notice that your diagonals intersect each other. So maybe one diagonal bisects the other. This one kind of looks like it should be the same, but this one does not, right? So, so a conjecture. So for part B, I might write something like this, right? If it is a kite, then one diagonal bisects the other. Okay, so maybe that is a conjecture. What else do I know? I kind of noticed that this looks like a vertical line and a horizontal line. So maybe I might write something like this. If it is a kite, then the diagonals are perpendicular. Okay. Whatever we want to do in order to prove that they are either perpendicular to each other or that they are going to bisect each other is perfectly fine. Okay, so now let's actually prove one of these conjectures, right? So let's read to see what Carla did. So Carla says, when she draws a second diagonal, Carla noticed she has created 4 new triangles. So 1, 2, 3, 4. If any of these triangles are congruent, that may be able to help us prove our conjecture from part B, she says. So we want to examine the triangle below. So she noticed that she wrote some letters. So she wrote F, G, H, and E, right, for these letters. And then she also wrote that, that J is here. So we want to prove, so are these F, G, J, and H, G, J, are they congruent? So that's the first thing that we're going to start off with. Okay. So, all right. So where do we begin with this proof? Okay. Well, I know that originally Kip had started off with this triangle and made it congruent to that triangle. So that's the information that I'm going to start off with. I'm going to start off with that my triangle FGE, I think it was, is congruent to my triangle HGE. And I'm going to say given information, and in parentheses, I'm going to say, what last problem was that? This was problem number 3, right? So again, this is your, what letters were they again? I think they were F. This is your G. This was your H, and then this is your E. So it's all about Kipp's transformation. So I'm going to say given, and I'm going to say number 3. So that way we know kind of where it came from. Okay, so based on that information, right, I know that these two sides are congruent to each other. So I'm going to say that FG is congruent to HG. Circle that up, and I'm going to say that because these triangles are congruent, so I'm going to say CPCTC, right, for my reasoning. Okay, what else do I know? I know that G is congruent to itself, okay, and again, notice I can't use one letter because I don't know which triangle, so remember, you want to use 3 letters, so I'm going to say angle FGJ is congruent to HGJ, and again, the reasoning is CPCTC, congruent parts have congruent angles, and now I need a second one, or third one, and I already have a side and angle, and so here's my second side right here, and so I'm going to say, off to the side, I'm going to say that GJ is congruent to GJ, and this is your reflexive property. Reflexive. Oop, too far. Okay. So, based on this information, I have now proven that the FGJ and the HGJ are congruent to each other. So I get to say this guy with this guy and this guy. I now get to say that these triangles, these mini triangles, FGJ is congruent to triangle HGJ. And why do I get to say that? Side, angle, side, congruent. Now, let's go back and figure out which one we're going to prove. So let's prove that the kite, one of the diagonals bisects the other. So basically what we're saying is that this side is going to be congruent to that side. Okay. So based off of this information, I get to say that FJ is congruent to HJ. Okay. And I get to say that because of CPCTC, or congruent parts have congruent triangles. Since these are congruent to each other, I can then say that J is the midpoint. Okay, so I can say, based off this, J is the midpoint of FH. So the midpoint. And why do I get to say that? It's the definition of a midpoint. So def of midpoint, because again, it's the middle point. Because again, if this was 2 and this was 2, then this whole thing would be 4, which means that J would be would be exactly in the middle. Okay, which means that what was the thing that we were trying to prove? We're trying to prove that one diagonal bisects the other diagonal. Right? So then our final statement is that I get to say that GE bisects, I think it was GE, let's check. Yes, GE bisects, because this is the line that's bisecting the FH, bisects F. Oh, sorry, not FH. Yeah, FH. FH. Bisects. And why do I get to say that? Definition of a bisector. Okay, so that's just one way we could have done it. If we wanted to talk about the other one, right? Well, we could have said that this angle, we would have said that this angle right, is congruent to that angle. And if you add these up, these have to be, these are supplementary angles, right? They're a linear pair, which means that they have to add up to 180 degrees. Therefore, this side has to be, both of them have to be 90 degrees, and we have a perpendicular bisector. So we can kind of add a lot of different things, together. All right, let's take a look at another one, maybe a little bit easier one. All right, so what about a right trapezoid? Right, so consecutive angles occur at opposite ends of the side of a polygon, which means that M and P are consecutive angles. M and N are consecutive angles. P and O are consecutive angles. So examine the quadrilateral at the right. What is true about M, N, and PO? Right, so what do you notice about this line segment MN and PO? Right, hopefully pause the video and you can think about it. If you didn't pause the video, which is fine, we should have said that these are parallel to each other. Why are they parallel to each other? Because the same side interior are supplementary. Right? Because again, 90 plus 90 gives us 180 degrees, right? So if then statement, right? If this happens, then this would happen. So we can say something if a quadrilateral, because again it's quadrilateral, has two consecutive right angles, then let's say it's a trapezoid. It is a trapezoid. So just an idea. So let's go ahead and prove that these are that this is a trapezoid. Okay. So how am I going to start this? Right. I mean, I could start that this is a quadrilateral, but I don't need to. I'm going to start with this. I'm going to say that the measurement of angle M, because it's only one letter, is going to be 90 degrees. That one is given to me. So given. And I'm also going to say that the measurement of angle P is also 90 degrees. And again, that is given to me. I know that if I add these two measurements up, right, M and P, this will give me 180 degrees. And if I add them up, we can just use the addition property. So addition property of equality, right, new property. What do I get to say? So since those add up to 180 degrees, right, because I've said we noticed that these were the same sides, same side interior, I can say that MN is going to be parallel to PO. And we get to say this same side supplementary. Therefore, MNOP is a trapezoid. And we can say definition of a trapezoid. Okay. So really this chapter is pretty challenging because we will be constantly trying to create flowcharts, and you'll be filling in and kind of thinking about what we have to say in order for something to work. Okay, always be thinking about where are you trying to go. Right? It's an argument, right? I'm trying to argue that this is a trapezoid. What do I need to know in order for it to be a trapezoid? I need to have two sides that are parallel in order for it to be a trapezoid. How do I tell the two sides are parallel? Right? Well, same side interior have to equal 180 degrees. So be thinking about what you need in order to get the next step, so to speak.